Hi, welcome to the tutorial on binning and creation of dummy variables. By the end of this topic, you will be able to bin and create dummy variables for a categorical variable. Creation of dummy variables refers to the process of transforming a categorical variable into a set of numerical or Boolean variables called dummy variables, each of which has a value 0 or 1. The number of dummy variables created for a categorical variable depends on the number of unique values or levels that categorical variable has. For example, we know our categorical variable condition of house has 5 levels, that is excellent, good, fair, okay and bad. So we would create 5 dummy variables, one corresponding to each level. For any given row of the dataset, depending on the value of the original variable in that row, the dummy variable corresponding to value would take the value of 1 and other dummy variables would take a value of 0 as demonstrated in this simple table as shown on the screen. Now there are two things you can observe in this table. The 5 dummy variables in essence are representing the same information that the categorical variable does. Value of condition underscore excellent being 1 and others being 0 means that this house is in excellent condition, which is what has been conveyed by the categorical variable also. Similarly, you can check for other values such as fair, good, etc. etc. The second thing that can be observed from the table is, once you know the values of any of the 4 dummy variables, you can deduce the value of the 5th dummy variable automatically. For example, let's look at condition underscore bad variable. For the first row, since condition underscore excellent variable has the value 1, we can infer that condition underscore bad will be 0, since a house cannot be simultaneously in excellent condition and bad condition. Similarly, you can check for other rows as well. For the last row, once you know that the value of other 4 dummy variables is 0, you can infer that value of condition underscore bad variable has to be 1, since that is the only option left. In that sense, condition underscore bad is a redundant dummy variable, since whatever information is provided by this variable can already be deduced with the help of the rest of the dummy variables. Hence, we can drop this variable. So, in reality, if a categorical variable has n levels, we need to create n-1 dummy variables for it. It is worth noting that we would choose the dummy variables for any one of the levels and not just bad, and nothing would change in our analysis. We just happened to remove dummy variable for bad level since that was the last level. Okay, so now you know what dummy variables are and how to create them. I'm sure you must be wondering, why do we need them? Why create so many variables when the same information is so easily represented by a categorical variable? The answer is because regression modeling requires all the independent variables to be numerical variables, and by creating dummy variables, we transform a categorical variable into a numerical variable. Once we create the required dummy variables for a categorical variable, we drop the categorical variable from our dataset, since we need only numerical variables in our dataset for model building purpose. We will be creating the dummy variables using the getDummies function of the pandas library. This function creates the dummy variable for different levels of the categorical variable and then drops it, as that won't be required for further analysis. Let's write the code for creating the dummy variables using the getDummies function. So we have transformed the categorical variable now. Now let's view the dataset by viewing the first 5 records. We have successfully converted this variable into dummy variables and it is ready for modeling. Similarly, let's convert the other 2 categorical variables, waterfront view and ever renovated, into dummy variables. So let's check the transformed variables using the head command. At times, we first need to bin a variable before creating dummy variables for it. This is also a variable transformation technique, and let's understand that now. If the number of levels for a categorical variable is more, say more than 20, then it would be better to bin these levels into fewer groups before creating dummy variables. Otherwise, you will have lots of dummy variables which would be difficult to manage. For example, the variable zip code has 71 levels, which would mean 70 dummy variables would be required. We can bin zip codes with similar average sale price into groups. Say, create 10 bins and categorize the zip codes based on the average sale price. To do this, let's first get average sale price across each zip code and arrange the output in ascending order of average sale price and name this table as zip table. Now we create 10 bins based on the average sale price and categorize the 71 zip codes into those 10 bins. And for that, we use the cut function. Next, we will be dropping the sale price from this table, as this won't be required as we have already grouped the zip codes based on the average sale price. So we write the code as shown on the screen. Next, we have to join this table with our original dataset. For joining the two tables, that is transformed housing dataset and the new table, that is zip_table, we will be using the merge function of the pandas library. To do this, we need an identifier or a joining parameter, which is a variable that is common in both the tables. The technical term for joining this parameter is key. We will be doing a left join here using zip code as the joining key. Now, what do we mean by left join? Well, when we join two tables based on the common key, one table will be on the left and the other will be on the right. Now, if it is a left join, then all rows of the left table will be returned along with matching fields from the other table. And for right join, it will be the opposite. All elements of right table will be returned along with matching records from the left table. Now let's write the code to join the two tables. One last step will be dropping the zip code variable from our original dataset, as we have already grouped this variable as zip code group. The code for the same is shown on the screen. Let's check how our dataset looks like now. This new variable zip code_group has 10 levels: zip code group 1, zip code group 2, and so on till zip code group 10. The only thing remaining now is to create dummy variables for zip code_group as shown on the screen. Let's check how does our dataset look now. It is worth noting that we could use binning for both numerical and categorical variables, and it is also an example of variable transformation. So with this, we conclude exploration and pre-processing categorical variables. The dataset has been named transformed_housing_data_2, and the link to the same is given in the helper text below. We will be using the same dataset in subsequent tutorials. See you then.